Well, all right, we're talking about modeling periodic situations, and here in this example, we're told that humans can hear the sounds of frequencies as low as 20 hertz, and then we're asked to find the period of the function. Now, the period and the frequency are reciprocals of each other. So, if the frequency is 20, then the period is 1 over 20, or if we can converted that to a decimal, it'd be about 0.05. Then we're asked to let the amplitude equal 1 unit and write a cosine equation to model the sound waves. Now, our basic cosine function might be like this without any translations. A, which is the amplitude, cosine B times theta. So now what is B? Well, to find the period, that's equal to 2 pi over the absolute value of B. And if we know that the period is 1 over 20, and everything we've done here before has been in degrees, now we have switched over to radians, which is okay. We know that one full circumference around the unit circle, is 2 pi. So 1 over 20 then equals 2 pi over the absolute value of B. And to solve for B, we multiply both sides by B, so the absolute value of B. So we got 1 over 20 times the absolute value of B equals 2 pi. And if we then multiply both sides by 20, that would allow this to cancel to 1. That would leave us with the absolute value of B equals 2 pi times 20, or B equals 40 pi. All right, so our amplitude is 1. So here's our equation. Y equals the cosine of 40 pi times x, or theta. And actually, we're dealing with time, so we could even say t. But anyway, we'll use this because this is how we're going to graph it in the calculator. Cosine of 40 pi x. Now, graphing these sinusoidal functions into a calculator, the big trick is, how do I set my scale on my x and y axis? Well, as far as my y-axis, we're going to fluctuate between 1 and -1. Let's say this is the x-axis right here. And for a cosine function, we're basically going to go from here like this. It's going to look something like that. And so if one period in this example is 0.05, and if I wanted to see 2 periods, then I'd set my scale, and this would be 0.05 right there. This would be 0. Half of that would be 0.025, and then we'd have 0.075, and then up here we'd have 1/10, 0.10. And so here's the scale that I would want to see, and that would actually show me 2 full periods on this sinusoidal or cosine function, which is y equal cosine of 40 pi x. So I find that the biggest trick in graphing these is getting that scale correct that makes some kind of sense. So now let's move over to the calculator, and we'll graph this and explore it further. All right, well, we're going to graph this sinusoidal equation where y equals the cosine of 40 pi x, or theta, or t for time, however we want to do that. It have to be x in our calculator. And since we're now dealing with radians, one of the first things I want to do, I want to look at my mode, and I want to see if I'm in radians. So I want to make sure I'm in radian mode. So I've done that. And let's quit out of here. And then I want to go in here and look at my window settings. All right, so we said that we need to be in increments of 0.025 out to. So I'm going to set my Y minimum out just to see a little bit of the negative side at negative 0.25. And I'm going to set my Y maximum because I'm going to look at 2 full cycles of 0.1 that we picked up from the other slide. And let's see, my scale needs to be also at 0.25. And my Y minimum, what else? What did I do? Oh, 2 decimal points. Let's delete that. Actually, it's the first one I need to delete. There we go. That should be okay. My Y minimum, I'm going to just set it at -1 because we don't have any issue with the amplitude in this. And I'm going to set my Y maximum at 1. And I'm going to set the scale for Y. I'm going to set it at 1. Okay. Now let's graph the function. So I got to clear out. I don't know what I was working on before, but it was some big stuff. All right, so we got the cosine of 40. And then we got pi, second caret for pi. And then x. Let's close our parentheses. Let's see what we look like here on the graph. Okay, which one did I graph that in? All right, so I got a full period. I don't know why we're not. Go back in here to my window setting. Change that edge scale to 0.025. See what that looks like. All right, there we go. All right, so one full period from this high point here to this high point here, and if my scale is at 0.025, then that would put this at 0.05, and that's what I know my period to be. I've got, I'm fluctuating between 1 and -1 because I had no change in my amplitude. My midline is still right here at 0. Or I could say that I've got a full cycle here from 0.025 to 0.075 period there. That's also at 0.05. And there we go. So the trick on these sinusoidal equations or functions is figuring out the scale. That's the biggest challenge, at least it is for me. And I had to think about, well, what's the period? And maybe I want to see 2 full periods. So there's 1, and there a high point. High point is number 2. I had to go back in and say, oh, well, if a period is at 0.05, then what's half of that? Then what's twice that? Half of that gives me down here at the halfway through the period. Twice that gives me 2 full periods. I know it seems a little complicated, doesn't it? It feels complicated to me too.